Hello everyone, welcome back to my channel. Today's topic is network security. We will talk about the introduction to network security and various different key parameters that need to be considered in network security. So let's get started. We'll talk about what is network security first. So network security is the practice of protecting a computer network and its data from unauthorized access, misuse of data, any modification or denial of service. It involves different practices to secure the network. So here you can see network security encompasses the protection of network infrastructure, devices, and data, which is essential for maintaining the businesses and personal data integrity in today's interconnected world. Then we have remote workers. We have the adoption of software as a service. And with that, there are emerging threats which continue to evolve. So, network security has become increasingly complex, yet critical for the organizations of all sizes, from small, medium to large enterprises. Now, we will talk about the different key parameters or key goals of security. That is CIA. Now, CIA stands for confidentiality, integrity, and availability. So, network security is built around these three key components that needs to be provided, and we have to make sure that there is CIA in your network, that is confidentiality, integrity, and availability. So these are the three security measures that are involved as this practices which are designed to ensure that the data is protected, that your network is protected. So your data resources across the private or public networks have to be protected with these three main key goals of security, CIA. Now, what is C? C is the confidentiality. And confidentiality means preventing unauthorized access to the data. Only the authorized users must have the access to the data. Then I is integrity. Integrity means ensuring that the data is not tampered, it is not changed during the transition. Then A is the availability, which is ensuring that the system and the data is accessible when needed for the authorized users. So, with proper security, organizations face risk of the data breaches, malware protection, and service disruptions that can lead to significant financial and reputational damage can be protected with providing proper security using this CIA model. Now, let's talk about the various different other measures that we can take. So, the basic network security concept is first you have to understand the network components. There must be endpoint security. Network components can be servers, routers, switches, firewalls, which form the backbone of the network infrastructure. There should be endpoint security. You have to harden the security of the networks, provide first-hand security with the policies configured, any protection required, antiviruses, all of that is the endpoint security or network component security, the hardware security. Perimeter defense, so network edge security, which provides the first line of defense against any threats which are coming from outside. Internal network is considered protected because it is not exposed to the external networks if it is working in isolation. But if you're connected to the outside network or public networks like internet, then there are chances of threats, and there is very commonly threats, attacks that can occur. So to protect your network through security from the external threats, protecting the boundary between the private network and the public network is required. That's called perimeter defense. Then, lastly, we have defense in depth approach, which means that you have to provide overall security, which is an effective security, relies on multiple layers of protection, continuous monitoring, coordinated security strategies. Now, let's take an example of airport. When you reach the airport, you have to take a flight. You have to go through certain levels of security, and different security checks are performed to make sure that everything is secured, checked, and verified, right? That's the same way, in networks, we have to provide security at different levels, which is called defense in depth. So, overall security is provided using different policies and principles and approaches required to make the network secured at maximum. Okay. So, the different security measures that we can take to provide the overall security or defense in depth is through firewalls. Let me write it down. We have firewalls as very important devices in network security. We have software or hardware firewalls. We have antiviruses, anti-malware, IDS, intrusion detection system, intrusion prevention systems, VPNs, access control. Yeah, network segmentations like VLAN, VRFs, right? Email security, web security, data loss prevention, all are the different security measures. All of these security measures can combinedly provide maximum security in the network. So these are the various different components of network security measures that we can take. So with that, we can provide defense in depth against the various different threat types. Now, by using this CIA trait, which is confidentiality, integrity, availability, we just discussed about it. So let's see a recap of what these three major components of network security means. So confidentiality ensures that the sensitive information is accessible only to the authorized users. So it protects the data or the resources from unauthorized access. The concepts used here or the processes used here are encryption of the data, access controls, and security clearances. Then next is I, which is integrity. Integrity maintains the data accuracy and trustworthiness, which means ensuring that the data is not changed, it is not tampered during the transition by any man in the middle, for example. So, what are the processes involved to ensure integrity? That is checksums and hashing is the process which is used to ensure integrity. Digital signatures are used, version controls. These are the processes used for integrity checks. Then availability. Availability ensures the reliable access to the resources or that the resources are available when needed by the authorized users. There should be redundant services or systems to provide availability of the resources or the data, disaster recovery, and DDoS protection or any kind of attacks that makes the resource or the server or the services unavailable. We must have a protection towards that to keep the service available for the users. Now, this in total or in combination would provide the utmost security in the networks. Now, there can be different type of threats we have to understand that what are the threats we have to protect our networks from. There can be multiple different types of threats towards which or against which we have to provide the protection, the defense we want to provide. We have to defend our network from the threats. The threats can be malwares, malwares like viruses, bombs, ransomwares. They can be phishing attacks, very commonly through emails. Um, DOS attacks, denial of service, or DDoS attacks, distributed denial of service attacks to make any resource unavailable or down. Man in the middle attacks can can also damage or even change the data. So any malware can be sent in that or unprotected data can be sent. Zero-day exploits, okay, which we are not aware of. There is no patch or a security measure we have for that kind of threat or any unauthorized or internal threats. All of these different kind of threats are there which can affect the network security against which we have to defend our network, we have to protect our network. Now, as we are talking about the defense in depth and providing security protection to the network, What are the different ways we provide security? I have talked about some of the components here, like firewalls, antivirus, anti-malwares, VPNs, IPS. So first, we will talk about the firewall. So firewall is a very major component of security here. We will talk about the evolution of firewall here. So I hope this is clear before that, which we have just discussed a basic introduction about what is network security, what is CIA, confidentiality, integrity, authentication, or availability in common security. Why do we need defense in depth strategy? We have just talked about the defense in depth strategy. Let me go back a bit. So, in defense in depth, we have talked about the different ways we can provide network security. Yeah, these are the three main principles which are used. Now, earlier when we talk about the networks, there was limited connectivity through the computer networks which existed in isolation. But today, it is no longer the same practice. The networks or users, devices, they are all interconnected. There are mobile users, remote users. The infrastructure is on site or cloud. Data is everywhere. We have to protect our networks. So, with this increase of networks, interconnectivity, with the ease of access, the complexity of the network, and the security is a challenge. So complexity of today's systems makes it important to implement defense in depth to ensure maximum security is provided to all systems, users, endpoints. So I want you to understand what we are trying to achieve here. That is defense in depth, a series of security measures, a building block that is designed to mitigate the increasing threat attached to the users or data or network, which provides a layered approach to the security or multiple levels of securities to mitigate the risk. Now let's talk about the firewall. So when we'll talk about the firewalls, first let's understand what is a firewall. Now, a firewall is a hardware or a software system that prevents the unauthorized access into or out of your protected network. Now, we have to understand why there is a need of firewall. So let's assume that you have an internal network, or we commonly call it inside network, which is commonly considered secure if isolated. For example, you have a switch here connecting a server. Let's say it's a web server. You have different devices here, PC1, PC2, and many other devices. Now, this is your internal network. It is in isolation, but as soon as you connect to other device, or other networks outside of the network, let's say you connect through the internet, and now your web server here in your network is no longer just provided for the internal users. You have decided to make it open to the public or for some customers which are accessing it through the internet. So let's say here is your customer network, and there are other networks. There are multiple different networks which are also there but not authorized. Let's say the hackers view. Now, someone from the hackers wants to connect to your web server. You don't want that. You want to allow the customer but not the other users, unauthorized users. But to provide this access, you have to connect to the internet. Now, to protect your network and to provide this security and filter the traffic based on this security implementation that you have done to allow only the authorized users to be able to access this web server, you will put a firewall. Okay. Now, firewall must have the spectacles to be able to see what is going through the edge or what is passing through this device to enter the network. So it will look at every packet that is passing through. And based on the rules configured on it, it will take an action. Action can be to deny or to, just a second. So the action can be to deny or to permit the traffic based on what action you have uh, configured. Okay. Now, this is one example of why we need firewall, what firewall can do. So firewall is a security device that monitors the incoming and outgoing network traffic and devices when whether they are allowed or blocked as desired. So firewall basically is a barrier between the trusted internal and an untrusted external network like internet. So now let's talk about the evolution of firewall. So in the early 1980s, 1989, 88, 89, the first firewall was introduced, which was stateless firewall. Now, stateless firewalls worked on five tuples. Okay, it works on five tuples. The five tuples are source IP, destination IP, source port number, destination port number, and protocol type. These are the elements which are used to provide the filtering. Now, stateless firewall has to examine every packet, each and every packet incoming or outgoing based on the defined rules. So it uses packet filtering mechanism. But the limitation here is it does not create any connection tracking. It does not have any information of or the track of the transaction that has occurred. So it is easy to spoof. That can be one challenge. Those attacks can be done in the stateless firewalls. Okay, so let's just go through the slide content here. First Gen firewall was introduced in 1988, the earliest firewall employed with simple packet filtering techniques, which examined individual packets, like I said, every packet, filtered by source, destination address, protocol, port. These are the part of the five tuples, and the protocol type, source IP, destination IP, port number, source port, destination port. It is stateless, so it couldn't track connections. These basically allow or deny the traffic based on the rules for allow deny configured by the administrator. Now, next evolution was the stateful firewall. Now, with stateful firewall, it maintained a connection state or a state table which has the information about the connections. So every packet does not have to be examined. So that reduces the consumption and it makes it more intelligent. Now, this was the second gen introduced in 1989, stateful or circuit level firewalls introduced with the capability to track the connections or connection states, which improved the security by maintaining a state table of the active connection. There was session awareness. So these firewalls could recognize and allow the traffic for from established sessions, like the sessions which was established from the inside, and the response is coming back for the session which was created from the inside or initiated from the inside, making them more user friendly while maintaining the security as well. The limitation can be, despite of these improvements, stateful firewalls remained vulnerable to the denial of service attacks through resource exhaustion. Resources were exhausting, and from tracking, numerous junk sessions could be created. If we talk about Cisco specifically here, so after the stateless firewalls, uh, PIX was one of the firewall which was created by Cisco, which was a hardware firewall, private internet exchange. PIX is private internet exchange, which was the first firewall appliance from Cisco, which is stateful firewall. Before that, the stateless firewall that we talk about was not a hardware appliance. It was like access control. This is an example of stateless firewalls. So PIX used to keep a track of the connections. A state table was maintained. A session or traffic which was initiated by the device on a trusted inside network are permitted. They are more intelligent. So this is an example of stateful firewall only. It was more intelligent, faster, handles layer 3, layer 4 security. But with stateful inspection or stateful firewalls, also the limitation is it is limited to layer 3, layer 4 security, but lacks layer 5 to layer 7 insights, advanced application layer controls, deep packet inspection was not there. So PIX was end of life in 2008. And then after that, Cisco ASA was introduced. That is Cisco. advanced application, adaptive security appliance, which was introduced in 2005. Now, adaptive security appliance ASA was also a stateful firewall initially, and then with more versions, with more intelligence were introduced. The features which were added in ASA were features like VPN, antiviruses, common filtering like the stateless firewalls as well, IPS, and the graphical user interface support. Okay. Then some zone-based firewalls were introduced, which were like the router-based iOS features for inter-zone policies. Networks can be divided into different zones, and between those zones, we can perform filtering. So these are various different detailed types of firewalls. But a major transition to the firewall types is next generation firewall. That is the modern firewall technology, next generation firewall. Now, next generation firewall, these are the latest evolution with deep packet inspection. There is application level inspection, intrusion prevention. So these are more intelligent. There is deep packet inspection up to layer 7. For example, Cisco Secure Firewall. This is a next gen firewall. There are different series of Cisco secure firewall called as Cisco Firepower, introduced in 2013. Then there was the Firepower Next Gen Appliance in 2016, introduced Cisco Secure Firewall. The latest one was introduced in 2021 and is used till present. All right, so we have just talked about the different firewall types and the differences between them. Now let's talk about some more security features or enhancements. So like next is the security intelligence. Now, what is security intelligence? It is an important tool in preventing the cyber attacks. Okay, so in today's evolving threat landscape, security intelligence has become the new perimeter defense, with sophisticated cyber threats rising dramatically since 2023 and projected global cybercrime damage reaching $10.5 uh, trillion dollar by 2025. Organizations must embrace proactive risk management powered by advanced security intelligence. So basically, security intelligence is a tool to prevent the cyber attack. This is the first line of defense today in the network security, and security intelligence feeds can be used to block the connections based on latest reputation intelligence. So this is a cloud-based service. It is having up-to-date threat intelligence. So with up-to-date threat intelligence, it has the information of the reputation score of the IPs, URLs, DNS. So it uses the security intelligence as a typical feature of next generation firewall, where a collection of IPs, URLs, DNS can be found. Now, from where the security intelligence takes its information from, that is actually updated by a group called Cisco Talis. Now, Cisco Talis is an intelligence group of threat researchers. They keep on researching and creating this database provided to the security intelligence, from where the network or the enterprises get the information about the security intelligence. Now, what is threat intelligence against which the security intelligence is provided? So, it is a comprehensive collection and analysis of global indicators of compromise and adversary tactics, techniques, and procedures. It enables the security teams to make faster, more informed decisions about emerging threats before they impact the operations. So detections or our SOCs, security operation controls with real-time threat defense capabilities that can be provided with the standards like MITRE, OSS. These are the lead developments of the critical frameworks. I have mentioned Cisco Talos. Talos is a group of researchers, threat researchers. Okay, so that is about the security intelligence. So information of the security intelligence is provided through various different standards and groups like Cisco Talis. Then Let's talk about the threat information standardization. Now, threat information standardization is a need in the network security. It is interoperability challenges. So there is diverse security tools and vendors which creates the different threat information sharing without the standardized format. This was a challenge. So a format was required. So this is a format. This is a standard actually, threat information standardization. So it provides the response in the form of sticks. Now, what is sticks? Sticks is structured threat information expression, which is used to share the threat data, the cyber threat intelligence. So sticks allows the organizations to share the cyber threat intelligence consistently in a machine readable format or a machine readable manner, where taxi is used. Taxi is a protocol, basically, trusted automated exchange of indicator information. It is a transport mechanism, the layer 7 protocol, which is used for this transport of the information. That is what the threat information standardization is. There is a response speed. So, standardization enables faster automated responses across different security platforms and reduces the time to mitigate the threats. There is analysis quality. So it is consistent, actionable threat data, improves the analysis accuracy, and enables more effective threat hunting and mitigation strategies. Okay, this is another component of network security. So the components I just talked about, sticks, taxi, and then it provides the information sharing. So Cyber Threat Alliance and information sharing and analysis centers, they promote cross-sector intelligence sharing through these approach. Sticks, which is a format, taxi, which is a protocol of sharing this information. Next, let's talk about network-based malware protection, some core approaches of network-based malware protection. So here we will talk about what is network-based malware protection first of all. So it acts on the files that are traversing the network, preventing malware file transmissions. Network-based malware protection is employed in Cisco Secure Firewall, uh, e- email security appliance, web security, Cisco Umbrella, CloudLock. These can provide the network-based malware protection. There can be cloud-based lookups, for example, Cisco Collective Security Intelligence Cloud. Response for the malware or unknown or clean file is received with the help of that. Okay, so there can be DNS filtering, there can be filtering based on the type of the file, the score of the file, the reputation of the file, all of that. Okay, so there is a blocking rate, there is an attack reduction with the network-based malware protection of up 90% and above, which is very useful for protecting the network. Next, let's talk about another very important component of the network security, that is IPS. IPS stands for Intrusion Prevention System. Now, intrusion prevention system was introduced before which there was IDS. IDS was intrusion detection system, but was limited to detecting and alerting. But it did not act. It did not have the capability to act, like to block the traffic or drop the traffic. It only protects the network. It what it does by monitoring the traffic. Now, IPS, intrusion prevention system, is one step ahead of IDS, and it also provides action, that is blocking the traffic, allowing the traffic. So IPS is built upon the IDS plus the intrusion prevention capabilities. It analyzes the traffic like layer 2, layer 3, ARP, DHCP, analyze and verify traffic like IP, TCP, UDP, ICMP, malware. It can analyze even the layer 7 app traffic or malware or service misconfiguration, all of that. Now, IPS identifies stop block attacks. Cisco Secure Firewall supports IPS. Service module can also be added on ASA, on Cisco ASA to provide IPS capabilities. So these are the different features which we can get through the different devices types to get the IPS service, that is intrusion prevention system. All right, so let's see what it does is it provides real-time inspection, automated blocking, deep packet inspection, intelligence integration, all of that. Now, after IPS, let's talk about next generation firewall. Next generation firewall features are it is agile, it grows with the organization. We have talked about next generation firewall briefly in the section where we talked about the different types of firewalls, evolution of firewalls. Next generation firewall is the modern type of firewall. So, an example of which is Cisco Secure Firewall. So, with next gen firewall, it provides integrated protection. It combines the traditional firewall capabilities with IPS, application awareness, advanced malware blocking, encrypted traffic inspection, decrypts and inspects and re encrypts the traffic to detect the threats hidden in encrypted channels. Threat intelligence can be provided, leverages the real time threat feeds through standardized formats for adapted filtering and protection. Identity-based access is provided. It enforces the policies based on users' identity rather than just IP addresses. Now, with next-gen firewalls, various different features can be added. Now, um, the features like, we go back to the previous slide and write features here. The additional features that it provides uh, compared to the previous firewall types are AVC, application visibility and control, IPS, intrusion prevention system. It can enforce the acceptable user policies, so policies can be implemented, SSL, TLS, decryption. It can provide real time awareness, and it can even provide automation for the intelligent security. So these are the various different features provided by the next gen firewall. Now, building a unified defense, there is this is the summary and the best practices we just discussed. So, integrating standardized threat intelligence is important through sticks and taxi, leveraging AI real-time feeds, which is provided through the next-gen firewall, deploy multi-layer network protection, which we talked about, that is defense in depth, and foster security collaboration, that is participate in threat sharing communities, standardization, which boosts the collective resilience against the sophisticated attacks. Next, let's talk about email content security. So, what is email content security? This is one of the major challenge, basically. Email security is one of the major challenge in the networks. Various type of data can be transported through emails, like files, phishing links, malwares. So we have to protect them. So primary attack vector is email, which remains the most common entry point for the cyber attack. So the credential attacks can be there. Attackers can use compromised credentials. Malicious payloads can be sent. There are different types of files which can be sent through the email. So email content security systems provides the email security controls. These are the types of firewalls and threat monitoring appliance for SMTP traffic for the simple mail transfer protocol. Cisco Secure Email is a physical or virtual appliance. Also, Cisco Secure Email Cloud Gateway is available for cloud-based security. Okay, so email security code protection is implement strong, unique passwords for email accounts, deploy advanced spam filters, maintain regular updates and security patches, train the users to identify phishing attempts, and encrypt the sensitive communications and attachments. So email authentication technologies are sender profile framework. This is a standard which defines which IPs are authorized to send emails on behalf of your domain, helping recipients detect spoof or any spoofed sender's address. Then domain keys identified mail, DKIM. adds a digital signature to the outgoing message that can be verified against a public key in your DNS record. So this ensures integrity. Domain-based message authentications should be there, which ties the SPF, sender policy framework, and the domain key identified mail together to specify the handling policies for the messaging that for the failed authentication. Now, next is web security. Now, major web-based threats can be driven by downloading some malwares or uh, some advertisements, phishing sites, cross-site scripting, unauthorized web applications. These are major threats through web. So, web access for businesses is a day-to-day requirement now, but maintaining appropriate web access for everyone with minimizing risk is a challenge. Web content security system provides the secure web access, content security, threat mitigation for web services to help the businesses, which act as a web proxy for the web traffic, HTTP, HTTPS traffic. So web content security works to protect the traffic, that is HTTP, HTTPS, which provides secure web gateway, advanced inspection, and policy enforcement. Next is DNS security. Now, DNS systems are frequent targets of the attacks. So, protecting the internal directories is very important. One example of cloud-based DNS security system is Cisco Umbrella. This is a DNS resolver and which blocks the malicious destinations. Next is AAA. AAA means authentication, authorization, and accounting, which is important to access all networks. Okay. So authentication verifies the user identity through username, passwords, biometrics, smart cards, or digital certificates. And authorization determines the access rights, role-based access, attribute-based policies, least privilege principles to provide the authorization to the user. Accounting keeps the tracks and log activities like audit trails, usage metrics, compliance reports, all of that. Then there is identity and access management. Now, identity and access management is for the increase in the use of mobile devices or let's say on an average, a user uses 3 devices at least. More devices means more attack surface. With introduction of software as a service, or virtualization, the attack surface increases more. So, identity and access management is a solution to provide simplified mobility experience to the enterprises. So, it provides a centralized user control. It can have multi-factor authentication to authenticate the users and lifecycle management for comprehensive identity and access management. Then next is VPN. VPN is virtual private network, which is a logical network which is virtual, a logical network independent of the physical infrastructure, private because it provides privacy through cryptography to secure your network, and network is the interconnection of the devices. So virtual private networks create encrypted tunnel across the public network, securing the remote access to the private resources. It provides end-to-end encryption, protects the data in transit. Authentication ensures only authorized access. Tunneling protocols used here in VPNs are IPsec, SSL, WireGuard. Split tunneling can optimize the traffic routing. Some modern VPNs are essential for secure remote work and accessing the internal resources from any location, like for the users working from home, for example. Lastly, the last component of network security we'll discuss today is network security device form factors. Now, network security device today are physical appliances, virtual appliances, cloud-based security services. So, with increase in cloud-based services by enterprises, cyber attacks on the cloud environment increased. So, it is important to understand the form factor of the network, be it physical, virtual, or cloud-based. The traditional security appliances were physical devices. For example, Cisco Secure Email Gateway was physical, but it connects to only the physical networks. For virtual networks, Cisco Secure Email Cloud Gateway can be deployed on virtual appliance like VMware ESXi or kernel-based VM. There is cloud-based security services which increase the efficiency, agility, like Cisco Secure Email, Cloud Gateway, and these forms of the services also have the similar features to a physical device or a physical server. It is ideal for small to mid-sized businesses, and there is less deployment time, effort, and it is highly available. It is cost effective, but here comes the challenge, which is the security, as more is the cloud-based or virtualization is there. So security have to be considered very wisely. So these are the different forms of the security device: physical, virtual, hybrid. We've talked about cloud also. Okay, so basically the trends and emerging challenges today, the evolving security landscape, that is cloud adoption. Zero trust architecture assumes no explicit trust, verifying every access request that should be enabled. Advanced persistent threats, which uses the sophisticated techniques to remain undetected. Ransomware attacks, which continues to grow in frequency and impact. IoT devices expands the attack surface. AI and automation, these are becoming essential for threat detection and the response. So these are the various different components we have talked about. So finally, winding up the topic, the conclusion and the best practices is we have talked about defense in depth. We have talked about various different topics and components of the network security that have to be considered to provide defense in depth. We have to understand the security fundamentals, focus on the strong authentication, logging, accounting, authorization. These fundamental practices must be followed. Strategic importance should be there. You have to be following the standard approach. There should you should be consistent and up to date. Okay, so these are the various different components, practices that we have just discussed about network security. I hope you have liked the video and it will be beneficial for you. Thank you for watching.